Okay, now 5.4 says what? Oh, this is the exponential function, right?
Yes.
You see now there's a connection between exponential function and ln x. Do you know that? What is the connection between these two? Exactly. The inverse of one guy is another, right?
Yeah.
Okay, so that's a good point. So we know that. So exponential function. Oh, I told, I forgot to tell one thing here. So how do you draw ln x function? ln x function is a kind of increasing function. When you increase x, function should go up, right?
Right.
But for exponential function, what do you think? Yes, that is also an increasing function, but it is increasing this way, right? So these are the two functions. Now you look at there, the domain of ln x is positive, but for the domain of exponential is all the way from negative infinity to positive infinity. All the real numbers are included. Isn't it? Okay, right. Now here again we have a couple of points. What is the derivative of e to the x?
Mm,
E to the x, same.
e to the x. Yeah.
Not only that derivative, antiderivative also the same. Easy to memorize.
Yes.
Okay. So now these are the basic problems. So this is just to get some kind of warm up about the exponential and ln. How do you solve this equation? Solve for x. It's not easy now because unknown. X is at top. It's very hard for us to find x. But if you see here, only thing is simply take ln both sides. Just take ln log both sides. Okay.
Yeah.
Now use the exponential property for log. Inside the exponent function should be pulled outside of ln. So x plus 5 times ln e equals ln 8. Am I right?
Yeah.
Okay, now tell me what is ln e? What do
Mm,
you think?
1.
1. Very good. Ln e is always 1. E to the power ln e is always going to be what? Ln e is 1, right? You
Yeah.
have here. So if you're plugging that one here, that is e to the power 1, which is e.
Oh, e. Right.
In general, e to the power ln any function inside is just fx. What does mean by this? This means e to the power ln of sine x is simply sine x. E to the power ln, you may have any kind of complicated function. Say here you have x squared plus sine x. And what is that? That is simply square root x squared plus sine x. You see that?
Yeah.
So this is very, very useful relationship between exponential and the function, simple function. Okay. Again, you have exponential properties for like a number you learned in high school. All the properties can be applied here also. You see, this is the one I'm talking about. X could be any number, right?
Mm-hmm.
Okay, this one is another one. Could you just justify this relationship? Why this is true? Why ln e to the power x is x? Exactly. You could pull this power in front of log, so that is equals to ln e, but ln e is 1, so x times 1 is x.
Yeah.
Makes sense, right?
Yes.
Okay, that's it. Now you have all the u substitutions and finding the derivatives. So whenever you have the fraction, use the quotient rule you learned and the product rule, then exponential rules. That's it. Then after that, use the u substitution to find out the antiderivative of a given function. Okay. So you see now, if you have like this problem, whatever you have in the exponent, you could take that as u. So use the u substitution. Say u is sine x here. If u is sine x, then du is going to be cosine x
Negative
times
sign or cosine.
positive cosine dx. Now look at
Right.
that. This factor cosine x times dx right over here in the problem, right? So for cosine x times dx, we could simply replace by du. So that means this could be written as, right, e to the power u times du. Do you see that?
Yeah.
Okay, now it is very simple. Antiderivative of e to the u is e to the u plus constant. But my u was sine x, so it is sine x. Very easy, applications of, you know, use substitution here. Okay, here, how do you approach this problem? Exactly, the whatever you have, the difficult part or
Yeah.
complicated one can be taken
Yeah.
as the u. So here u
Yeah.
is 1 minus e to the x. That means du is the derivative of 1 is
Negative.
0 dx, right?
Yeah.
Now,
Your dx, would you
you don't need to find u dx. You already have here ex times dx.
Yeah.
So ex times dx, simply move this negative sign to that side. So e to the x
Right.
times dx is nothing but negative du, right? So it is
Yeah.
negative du in the numerator over my denominator is now 1 minus e to the x, which is simply u, right?
Yeah.
Okay. So there are a couple of things now you could try. One is changing, the limits, the original limits to the u limit, or find the answer of this integration. Then you could go back and replace by your old variable. Then you could use the same limits, isn't that? So either way, yes, you could do like this also. But now I'm not doing. I'm just simply first finding the
Solving.
antiderivative. What is the antiderivative of 1 over u? That is ln u, right?
Yes.
Now what is my u? My u was 1 minus e to the x. Now you see, I go back and, changing the variable into original. Now you could plug in that original bounds 0 and 1. In this way, you don't need to, have the new variable. I don't want it. Because when you plug in these two, you will have a kind of a difficult number in your upper bound, right? If you're plugging 1 here, your u will be 1 minus e. Then when
Yeah.
you're plugging, you may have some difficulty in in simplifying. To avoid those things, I am simply using my original variable without changing upper bounds. Go back and switch into x, then plugging the original variable. Makes sense, right?
Yes.
Yes. Now negative sign is common. Plugging first upper limit. Upper limit x is 1. So e to the power 1, which is ln 1 minus e. Then subtract the lower limits. That is 1 minus e to the, I believe so. So what's the answer I gave in answer column? Do you remember? Oh, that's the reason I switched the problem here to plus sign. Typo.
Oh, okay.
Yeah, otherwise, you will in trouble to find out the real value. So yeah,
Right.
sorry for that. So that's what I'm not finding answer here because ln0 is unbounded. Okay, so switch the problem to plus sign. Now there is not ln0, that is ln1. ln1 is 0, right?
Yeah.
So answer is ln1 plus e.